Hey algebra class, we are going to be working on translating functions today. I have 4 different colored pens today. I don't know if you're going to want to get that. I happen to have a green, a red, a black, and a blue. Feel free to grab them if you want. So today is 12, 11, 17. We're talking about translating functions today, and we are going to be, our essential question is, how can I translate between different representations of functions? So over the past couple of days, we've really talked about different types of functions. The particular ones that we're going to talk about today are going to be verbal. The equations I'm going to do in blue. My graphing, I'll do the table in red, and my graphing in green. You're also maybe going to want a straight edge of some sort. I'm going to use a Post-it note. So go ahead and go grab those right now, pause it, and come on back. Actually going to do this page as kind of your at the end of the lesson page that you check yourself out with. So, and we're going to talk about what each one of these forms, what information each one of these types of functions give us. This is called slope-intercept form. It's the y equals mx plus b. And when an equation is in slope-intercept form, it's going to tell us that this is my slope. And our slope is telling us kind of our change. This is called a delta. Our change in y over our change in x, or how steep our line is. Our slope is also the idea of that number that is multiplied by our independent value to give us our function. The other thing that an equation gives us, this is called our y-intercept. It's also that constant when I'm looking at a equation. And it's that idea of where our line crosses the y-axis. Okay. The other thing, and we're going to talk about it a little bit later, and so I'm just going to write it in here. There's something called standard form that we're going to do later. And that is, and we're just going to write it down, ax plus by equals c. And this form is when we have this piece right here on this side of the equation. So I'd have mx or our ax plus by, whatever is here, and remember this is the same thing as saying 1, equals our constant. So we'll get to that later, but this is called standard form. Graphs can show us lots of things too. So we talked about just a second ago how this y-intercept is where our line crosses our y-axis. So right there, that right there is my y-intercept. And it's also telling me my slope, or my change in y over my change in x. What I'm doing is, if I choose that this point is right there in the middle and I look for my next point, which is right there, this is going down 1 and over 2. So my slope, my change in y over my change in x, well, my change in y was going down 1, and I'm moving over 2. So that's my slope. Table, when I have an xy table, and we're always going to use a special set of x values. We're always going to use -2, -1, 0, 1, and 2 when we're not given any values. What these tell us is this idea of, sorry, if I give myself some values here, and I'm just making these ones up as I go. Tables can show us all of the information that these are telling us. So this is my independent variable. This is my dependent. I can find my slope, my change in y over my change in x, by just going like this. I'm going up by 4, up by 4, up by 4. So my change in y is a +4 over, and then here I'm going up by 1, up by 1, up by 1. or it's just a solid 4. Let's see. It can also tell us what our y-intercept is when I find that value when x is 0. So when x is 0, my y value is the y-intercept. And then finally, verbal expressions, they can tell us that idea of what depends on what. They can also give us our rate of change often. We're looking for those key words of per, every. Anytime that we see those multiplication keywords, that's giving us our rate of change or our slope. And it also tells us that any constants are our b up here, and they are also our y-intercept. Okay. So now that we kind of talked about what each of these forms show us, what we're going to do is we're going to kind of go in between them. All right. So now we're going to start, we're going to look at this linear function, and it says, use the information given to complete the other representations of the linear function. Then answer the questions at the bottom of the page. So they gave us the only information, I have a blank, blank, blank. The only information they gave us was this equation, and this equation happens to be in standard form. So I need to get this equation into y equals mx plus b. So the idea is I need to get y on the left side all by itself. So if I need to get rid of this, I'm going to subtract it, 3x, because it's a positive, right? And then I'm going to subtract it. These cancel out. I'm just left with y. I can't combine these, so I get negative 3x plus 4. So in slope-intercept form, I get y equals negative 3x plus 4. Now for my table, I'm going to use those special x values because they're not giving me anything, so I'm just going to make up my own x values. I don't have any to pull from our graph here. I don't have any x values in my word problem. So I'm just going to use those ones. So we're going to use negative 2, negative 1, 0, 1, and 2. And the idea is I'm going to go ahead and plug this negative 2 in for this x. So negative 2 times negative 3 is 6, plus 4 is 10. Now I'm going to plug in this negative 1 in for that x. So negative 3 times negative 1 is 3, plus 4 is 7. Go ahead and pause the video and finish out this table. All right, here's our table filled out. Okay, so now we're going to go into the graph. Because I know that my y-intercept is right here, it's also right here. It's this idea that this is where this crosses, our line is going to cross on our y-axis. So when x is 0, my y is 4. So I'm going to go ahead and just put a dot right there. Now, because I've already got a table, there's a couple of things I can do. I can go ahead and just plug in my plots, or I can use the information of my equation. So my slope means negative 3 over 1. So I'm going to go down 3 and over 1. And my y-intercept I just pulled was 4. So I'm going to show you how to do this once while just using the slope, and then a couple of times while we're using the points. So actually, let's use this point right here. Negative 1, 7. So I'm going to go to negative 1 and then up to 7. But I can also use my slope of down 3 and over 1. And if you notice, I go down 3, 1, 2, 3, over 1. 1, 2, 3, over 1. And if I look on my graph, I should have a 1, 1, and I do over here. Go ahead and pause it and finish out your line. All right, I've got my points, so I'm going to go ahead and use my straight edge that I got, and I'm going to connect and then make them a line here. All right, Finally, we're going to go ahead and just read through the verbal description. So the verbal description says, a graph of the function contains the point. I'm just going to use my y-intercept point. So my y-intercept point is 0, 4. And when the value of x increases by one unit, the value of my y decreases by 3 units. And now I'm just going to go ahead and answer these questions. Is the slope of the line positive or negative? Well, my slope is negative. It was going down. I can see that my slope is negative right here too. So it's negative. I know this from the equation and from the table for sure. Just by looking. I could do some extra work here, or that word decreases. It also tells me, but I can just look. I see that negative and I see this. When the value of x increases by 2, what happens to the y value? So when I go up by 2, what is happening to my y value? Well, it's decreasing by 6. Which one tells me that? It was super easy to see straight from the table. It's also pretty easy to see from right here. If I move over 2, what's happening to my x? Oops, this should be graph. Sorry about that. All right. And then finally, what is the value of x when y is negative 5? I don't have my y being negative 5 here. I could plug in a 5 and do some work, but I can also just look at my graph and find out where, when y is negative 5, where is my x landing? So if I keep going, 1, 2, 3, and over 1, I get that right there, and that's my 5. So when y is negative 5, my x value is 3. So for sure, my graph really helped me out on that one. In this case, our verbal was only really told to us by this word decrease, and it's really only when we're looking for our slope that our verbal description really helped us. That being said, you can see how different ones were easy to see each thing at one time. Okay, I've moved on to page 2. So on page 2, this time I don't have an equation, I don't have a table, I don't have a verbal description, but I do have a graph. So we're going to take a peek at what information I can pull from our graph to kind of build these other 3 pieces. So if I look, I know that my y-intercept is right there. It's that part where my line is crossing this y-axis. So my y-intercept is 6. And then I can pull out my slope by noticing that I for sure have a positive slope. And what I'm going to do is I'm going to find another point where that line is crossing directly in between these axes. So what I'm going to do is I'm going to say, okay, how am I getting from here? What's my rise? How far up or down am I going? Well, in this case, I'm going up 1, 2, positive 2, and then I'm going over 1, 2, 3. So my slope is positive 2 over 3. I'm sorry, my y-intercept is negative 6. All right. Now, because I have these 2 pieces of information, I can for sure come on up into here and do my y equals mx plus b. So my equation is going to be y equals, my slope is 2/3 x plus negative 6. You could also just write y equals 2/3 x minus 6. Okay. Now there's a couple of different ways that I can do my table. The last time I showed you how to do the table by putting in that special set of data where we have the negative 2, negative 1, 0, 1, and 2. But you can also pull your points from here on your graph. So we already named that 0. I'm going to put it in the middle. 0 was negative 6. I also found this point right here. So when my x is 3, my y is negative 4. I'm going to go ahead and pull this one. When my x is 6, my y is negative 2. Now you could either start seeing the pattern and fill it in, or you can keep going and finding a couple more. So right here, when my x is negative 3, my y is negative 8. And I actually have one right here. When I have negative 6, my y is negative 10. Okay. If I notice, I also have, this is increasing by 3. this is increasing by 2. So that idea of my change in y over my change in x, I get positive 2 over 3, which matches here and it matches here. Okay, the graph of the function contains the point 0.06, sorry, 0, -6. And when the value of x increases by 3 units, the value of our y increases by 2 units. And that helps us with our slope here. It matches, all of these pieces are matching. All right, what is the value of our x-intercept? Well, if our y-intercept is where this line crosses our y-axis, our x-intercept is where it crosses our x-intercept, or it is our x-axis, or it's when our y is 0. So I can see that piece right there when it crosses this y-axis, or our x-axis, our y, when our y is 0, our x is 9. What told me that was the graph. I might have gone one more further here, and I might have had this. But since we didn't, it was for sure my graph, but maybe my table if I would have gone further north instead of south here. What is the standard form of the equation? This was that idea of I need to get this value right here over here, because standard form, remember, and I'm going to write this over here, standard form ax plus by equals c. So I'm going to go ahead and I'm just going to kind of manipulate this. So we're going to have, I'll do it down here in our notes. I'll do it over here. So I have y equals 2/3 x minus 6. I need to move this over. So because it's positive, I'm going to subtract it. We end up with, this is our ax. Because this x and this y cannot combine, I'm going to end up with my ax is 2/3 x plus, remember this is a 1 y equals -6. So -2/3 x plus y equals -6. What helped me find that? The equation. All right, and then finally, what is the value of y when our x is 60? Well, I don't have 60 on here. It's too hard for me to see where 60 is right here. This doesn't really help me, so I'm gonna go ahead and just plug in 60 for this x over here. So I'm gonna say, okay, y equals 2/3 times 60 minus 6. 2/3 of 60 is 40. Minus 6, and 40 minus 6 is y equals 34. What helped me? The equation. Go ahead and summarize down here and add any questions that you're having here to go over tomorrow in class. All right, this is our final example. In our final example, they're giving us the information from our table. So you can see it's pretty much filled out, but we do have this guy right there that we need to figure out. However, this is a pretty easy table, so let's go ahead and just find our change in our x values. So our change in our x values is that it looks like I'm adding 3. Because these are linear functions, I know that this is going to be a consistent going down, up 3. I also know that this is going down 4, so I know that I can just go ahead and plug that in there. So 10 minus 4 is 6. Okay, because when I'm looking at equation, I know that my equation is my change in y is -4, my change in x is 3. That's my slope. So when I'm writing my equation, I get y equals my slope of -4/3 x plus whatever my b is. Now remember, your b is your y-intercept, so it's your y value when your x is 0. So my b is going to be this 2. And I'm getting that because my x is 0. I'm actually going to come on over here and do the verbal piece next because I've got some answers. I already know when my x is 0, my y is 2. And I already know my changes. So as x increases by 3 units, the value of y decreases by 4 units. Finally, I'm just going to do my graph, and I can pick any one of these to do my graph. So I know that my slope is down 4 over 3, and I know that my y-intercept is 2. So I'm going to go ahead and put my 2 dot there, and then I'm just going to follow the instructions here. So I've got -4, 1, 2, 3, 4, and over 3, 1, 2, 3. I can check my work. When x is 3, my y should be -2, and it does work. I can also just go ahead and follow these points. So 6 and -6, and -3 and +6. And that's kind of enough to get this graph. So I'm just going to go ahead and draw my line, call it a day. All right, what is the value of y when x is -120? Well, I don't have -120 in here. I don't have -120 here, and I don't have -120 here. So I'm definitely going to need to use this equation to help me find that. So I'm going to go ahead and rewrite it down here. So y equals -4 thirds times -120 plus 2. I know that when I'm multiplying, I need to go like this, and then I just multiply across. I know that I'm going to get a positive number. So I'm going to get this y is going to equal 480 divided by 3 plus 2. Finally, I get y equals 160 plus 2, and y equals 162. And the equation helped us. What is the value of x when y is 10? Well, when my y is 10, my value of x is -6. I could maybe also find it here. When my y is 10, my x, sorry, what is the value of x when y is 10? Sorry, when I have 10, my y is going to be over here. So maybe if I would have kept my thing going, I would have noticed that that's at a -6. So I definitely used it out of my table. I could have gotten it out of my graph, and I very well could have also set up my equation. 10 equals -4 thirds x plus 2, and then solved it to find x. So I could subtract 2 and end up with 8 equals -4 thirds x, then multiply by 3/4. Either way, any way, you can get that value right there. All right, so you should be summarizing each one of these pages. And then what I want you to do is I want you to go back and I want you to fill this out. We're going to go over this in class, but from a table, what information could be easily found using this representation? So we kind of talked a lot about that here. What information would need to be given to make this representation easy to create? When would this representation be the best choice? Or I'm sorry, is not. So your job tonight is to kind of talk about or do this. I'll have this and my answers up on the board, and you can kind of check them. Your answers might be different from mine, so I'm going to go ahead and stop my video here. Class, hope you have a good night.